Have the exact same question. We just answered the exact same questions from this morning. And so this problem, this is chapter 9, so this is not going to be on your test. I mean, in fact, but it should still be easy to answer. Stronger oxidizers and weaker oxidizers are driving force for double replacement reactions. True or false? True? Actually, this one is false because double replacement, there are no oxidizers, no reducers in double replacement. Double replacement, the ions, they don't change. You know, the oxidation state doesn't change. So, since that happens, we don't have any electron transfer, and therefore for double replacement, we look for something else. What's the something else that we look for in double replacement? We look for precipitation, stronger to weaker acid. Sounds similar, but it's different. Stronger to weaker acid or gas formation. We're going to see this again, so you can't forget about this. This is going to be a big part of the final. So make sure you keep reviewing it until it clicks, until it kind of sticks there. Question 2 is also chapter 9. Metathesis reactions consist of favorable ion combinations. This is not chapter 9, this is an earlier chapter. I forgot what chapter it was. A mole of carbon-12 atoms weighs exactly 12 grams. Is that true or false? That's true, by definition. Yeah. This was over the summer, so over the summer I mixed it up. The order presentation. Number 4, we talked about this one yesterday. These are mole ratios or volume ratios. Volume ratios if they're all gases. Volume ratio doesn't work if you have a liquid or solid. Mole ratios always work, whether it's solid, liquid, or gas. The equations, mole ratios will always be true. But mole ratios aren't the same as mass ratios. If the chemical equation were written as mass ratio, then 2 moles of hydrogen would weigh 4 grams. A mole of O2 would weigh 32 grams, so it would be 4 H2s, 32 O2s. And 2 moles of water would weigh 18 times 2 would be 36 grams. And so this would be 4 grams plus 32 grams yields 36 grams. That would be a mass ratio. But when we write equations like that, they are mass ratios, so mole ratio. So number 4 is a chapter 10 problem. Number 5 is also a chapter 10 problem. Number 5, we did percent yield, which is based on the actual yield and the theoretical yield. So the formula for the percent yield, you should know that. What is the percent yield?
The actual yield over the theoretical yield times 100.
Yeah. The theoretical yield is 98.3, the actual yield is 91.5. So it's 91.5 divided by 98.3 times 100, which gives us 93.1%. Is that what you guys got? Actually, this morning, no one did the practice test, so we just did it all together. We could do the same thing here. This is chapter 10 also. What ions are present in what ratio, and in what ratio in a solution of aqueous calcium chloride? So which one looks the best? C. This Cl2 minus doesn't even work. I mean, this plus 2, this minus, well, that's impossible. Plus 2 minus, that works, but what is Cl2 2 minus? Doesn't exist here. Chlorine's a -1, not a -2. None of those others would C. 7. Weak acids are weak electrolytes. That's true. 8. HF is completely ionized in water. That's false. HF is a weak acid. It's a weak acid, but it's like the most feared acid of all. One of the most feared acids. Not because of its acidity, it's because of something else. Other ways it can react. 9. Which of the following substances will precipitate from, this This is supposed to be an aqueous solution. So which of the following which ones are insoluble? Well, not all group 1 salts are soluble. Ammonium salts are soluble. Group 1 salts are soluble. Acetate salts are all soluble. Carbonates aren't. It's got to be D. Carbonates are all insoluble except for group 1 and ammonium. So D will precipitate. D won't dissolve. 10. In the combustion of methane, according to the equation, how many grams of water are formed during combustion of 4.2? This is supposed to be 4.24 grams of methane. Get rid of that period and a G there. So this is your basic stoichiometry problem from chapter 10. And so the way I do stoichiometry is I like to set it up via dimensional analysis. So this is the way I use it. 4.24 grams of methane. And then we go grams of methane to moles of methane. And then moles of methane to moles of, what do we want? What are we after? So we can go from moles of methane to moles of O2, moles of methane to moles of CO2, moles of methane to moles of water. We're interested in CO2 or water. We're interested in water. So what we'll do is we'll go from grams of methane to moles of methane, moles of methane to moles of water to grams of water. And so to do a gram to mole conversion, we need the molar mass. Carbon's 1201, 4 hydrogens is 404, so that gives us 1605. 16.05 grams of methane per mole of methane. So grams of methane cancel. You know what? I don't even have to have that strategy. I came up with a strategy because that's basic stoichiometry pattern, but you don't need that. We just try dimensional analysis. We just try to cancel. For example, the next thing we'll try to cancel is moles of methane. Well, moles of methane, we have lots of different branches where we can go, but we want to head towards water, so one is a 1 to 2 mole ratio here. And so for every 1 mole of methane, we're going to form 2 moles of water. So moles of methane cancel, it leaves us with moles of water. We can do a mole to gram conversion using the molar mass. Water is 18.02 grams per mole. That's oxygen 1600, 2 hydrogens is 202. So I got that from taking 1600 for oxygen, and then 2 hydrogens would be 202, which gives me 1802. There. But I use it so much that I have it memorized. You don't have to have it memorized. And so what does this come out to? Let's get the calculator and see. Sometimes, let me tell you, sometimes, we do test a little bit differently, depending on the type of test. So for example, if you take a standardized test, my strategy is a little different. Standardized tests are purposely meant so that no one finishes. No one should finish a standardized exam because what they want to do is they want to spread out the students. They don't want them all bunched up at the top, and they don't want them all bunched up at the bottom. So what they do is they try to make it a certain level so that no one ever scores the top score, because if you get people scoring the top score, that is, if you get a whole bunch of people scoring 100, then you don't know, out of those people scoring 100, who would have gotten the higher score. In other words, you don't want an artificial ceiling on the test. And so what they make it is they make them impossible to finish, or they try to make them impossible to finish. And so what that does is it rewards speed, And so when you have a test that requires speed, then you have a slightly different strategy. And so I've had lots of tests. In fact, I often debate this myself because I think, I don't push speed. I don't have a time where you got to finish it pencils down at this time, everybody. But it's good to have that because then you'll be training yourself to use little tricks here and there for speed. One of the tricks is not to punch this out in your calculator. If you punch this out in your calculator, it takes time to punch out the numbers. And so what you do is you just look, you know, you just get a rough estimate. 18 divided by 16 is a little more than 1. 2 times 4, 8, a little more than 8. And so we were expecting an answer a little more than 8. Impossible, right? Impossible, impossible, impossible. The only possible answer is E. And so I just saved myself punching buttons on the calculator. And so this is a technique that you would do if you're taking like a standard test or you're taking a time test. You know, you try to avoid having to punch the numbers in your calculator so that you can maximize speed. I personally didn't like those tests because, you know, you could know the most material and have mastered it, but just are a little slow. And if you're a little slow, your grade's going to suffer. Or you know, if you like to take time. Well, anyway, another thing that comes up is this. That answer is 9.51, but I got 9.520. Would I sweat it? I wouldn't sweat it because, you know, that's probably round off. You know, I probably took this number from the book. If I took this number from the book is, you know, rounds differently than I round. So, you know, if we're within that, I wouldn't even give it a second thought. I think that's round off. The way they rounded differently than I. Now, if it was a bigger difference, then I might start to worry. But you know, usually you don't want to worry about little differences like that necessarily. Sometimes you do, though. You know, a lot of test writers know that people try to, you know, do the process of elimination, whatever. So sometimes they'll put a cluster of numbers around 950. You know, if you got a cluster of numbers, then it makes a difference. You got to be very careful how you round it because you want to be following proper rounding techniques. All right, number 11. Actually, you know what? I didn't ask. Did anybody do this or try this? You did it? Since only one person did, we're going to just go through it. I think nobody did anymore. Good. Let's take a look at PCL5. What's PCL5 called? Phosphorus penta's 5 chloride. This would be 2 words, phosphorus space pentachloride. Pentachloride is all one word. Phosphorus pentachloride can be produced by the reaction of PCl3, which is phosphorus, and Cl2, which is chlorine, to make PCl5. What mass of PCl3 must be used to produce 127 grams of PCl5 if percent yield is equal to 20%? So why don't you try this one out? You know, imagine that we're taking the test now, and then try. If this question popped up on the exam, could you get it? So give it a shot and see what you come up with. I'll give you some time to work it out.